Some series to integral calculus. Some series to integral calculus. There are many ways to get some series to integral calculus. We are seeing it. Okay, probably we will take it later. 1 cube, 1 to the power 3. There are, okay, there is a summation series. There is a summation series that is 1 to the power 3, another is 2 to the power 3, another is 3 to the power 3, another is 4 to the power 3, another is 5 to the power 3. Means this is the summation of the series. 1 to the power 3 plus 2 to the power 3 plus 3 to the power 3, or in summary, I can say x to the power 3, what it would be. I was trying to see the solution. And solution is some induction. Consider n equal to k plus 1. You have the problem 1 to the power 3 plus 2 to the power 3 plus 3 to the power 3 up to n to the power 3 equal to, you have the solution. And then consider n equal to k plus 1. Very long discussion is going on. I'm not scary of the long discussion. Long discussion are good, but problem is that for different kind of sum series, solution is different. How many solutions someone will remember? Not possible. We are seeing heavy traffic in these videos. In YouTube, our YouTube, we are seeing heavy watch time and traffic in these videos. Now, means people are surprised to know that there is only one way to solve all the sum series. It is not the end. We are trying to find only one way to solve all the artificial intelligence problem also. There are thousands of algorithms in artificial intelligence. If people they know, there are thousands and thousands of algorithms in artificial intelligence itself. If someone want to recognize voice is a very big thing, very big thing. If someone sees the kind of in voice area only, there are many applications are useful in voice area only. Voice cleaning means noise cleaning in the voice. There are again hundreds of requirements are there only in the manipulation of voice. Consider recording is not going on, and then someone has to clean the recording. Someone has to make the audio laudable. Someone has recorded, but it looks like it is recorded in hollow manner. Means there is a vibration that is coming in. Now he has to convert into a way that it is as good as he is talking near the mic, or someone has kept the mic very near and then it is hounding again. Then there are numerous applications in audio only. Not only that, if I have two audio source, if recording has happened from two audio source, then I have to synchronize the two at what time from two audio source that it is exactly same. What I'm trying to say, consider I am speaking and two microphone they switched on. Two microphone they switched on. Or if it is not satisfiable, I have a microphone through which recording is going on. And then this microphone is not perfect somehow. Okay, then I purchased a new microphone, but problem is this microphone is connected to the device, so generally recording will happen nicely through this microphone. Audio and video are synchronized through this microphone, but I have a better microphone and it is not connected to the recordable device, but it records in better way. I just kept it here and it records very nicely. Now, when I'm trying to see, then this microphone is feeble, where that microphone is very nice. But problem is video is attached to this microphone, not that microphone. How I can synchronize that microphone audio with the video? So that microphone audio has to be synchronized with this audio. Okay, there also we need artificial intelligence. There are thousands and thousands of ways someone would need a audio manipulation only, audio manipulation, video manipulation. So many things are there, and everywhere in one kind of audio manipulation only, like audio synchronization, public would see different kind of algorithm. That's why people run away from the mathematics. Biology is very good. Biology is very good. Someone can see a future in hotel management. Someone I have never I have never understood in my life what is called hotel management. There is something called hospital management. I never understood what is the study called management. There is a study called management. You have to study management. I could never understand. Okay, someone they go study biology. Someone they go study kind of become lawyer. Okay, law, this and that. If you see minutely, there are many people they run away from mathematics only. When they see the power, the complications in mathematics, then they generally run away. And mathematics, as I told, there are thousands of mathematical applications are there only in voice area. And in one area, again, in numerous algorithms are there. Now, what people would do? So, like now, the way we are doing all sum and series, people can find only through integral calculus. There are again infinite sum and series are there. We are doing one by one so that it would be clear to the people that how to tackle it. That's it. Otherwise, methodology is only one, that is successive approximation, through which someone would calculate the summation formula accurately. Accurately. Okay, but we anyway we are seeing a lot of rush, a lot of traffic in the in some and series video nowadays. People are now they are surprised that there can be only one way to find a formula for all summation and series certainly, and this is the most perfect way. Okay, to find the formula of all summation series. Anyway, we will finish the 2x minus 1. If time permit, we will start x to the power 3. 2x minus 1. What is the problem? Problem is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. I mean, there is series called 1 comma 2 comma 3 comma 4 comma 5 like that. Now in examination it is written, can you compute 1 plus 2 plus 3 plus 4 plus 5 plus 105? Can you compute? Write the answer. One answer is very simple, n into n plus 1 by 2. Okay, but we will do another way so that integral way of calculating the summation would be more clear to the people. So in that way, we have already in successive approximation, we have already discussed about two ways. One is right hand side way, one is left hand side way. We will try middle way. What is middle way? What is right hand side way? What is left hand side way? Okay, many times as we have discussed it, consider this is x-axis. This is x-axis, and we have x equal to 0, x equal to 1, x equal to 2, x equal to 3, like so. When x equal to 1, then I have a function called x, fx equal to x. Means when x equal to 1, this is y-axis, or function over x-axis. This is function over x-axis, and this is x-axis. Okay, if that is the case, then this is x equal to 0, 1, 2, 3, 4. What is the equation? Function over x-axis. Okay, what is function over x-axis? Okay, consider it is 1, 2, 3, 4, 5, 6. If I divide it into n different parts, then each part is 1, 2, 3, 4. Can all part behave same? Yeah, all part can behave same. True. Okay, then first part, that is 1, I can write it as x. Another part is 2, I can write it as x. Another part is 3, I can write it as x. Means we want x plus x plus x plus x, where x is variable. What I am saying is x plus x plus x plus x time, or x into x dx from 0 to n. X dx means function over x is x only. Okay, in that manner, if this is x equal to 1, 2, 3, 4, 5, 6, at x equal to x, function over x is x. If it is 1, then height is 1. When it is 2, height is 2. When it is 3, height is 3. When it is 4, height is 4. When it is 5, height is 5. If someone connects all the top point, it will lead to another line, and this line is function over x, and it is x. Okay, it is a straight line, and it has a tangent theta. If this is angle theta, the tan theta equal to 1. y equal to x, dy by dx equal to 1, slope is 1, tan theta equal to 1, means this angle is 45 degree. And this is what the equation is. What we are trying to calculate? We are trying to calculate this function is called fx equal to x, and this is a discrete function, point mass function. This is sampled at many points. This is not a continuous function at x equal to 1. So I would rather say I did x equal to 1, then height is 1, height is 2, height is 3. I took all the top point and connected through a line, and that line equation is fx equal to x, but that line is not continuous. It is sampled at x equal to 1, 2, 3, 4. Okay, then we have summation x equal to 1 to n. Summation means sigma sign. Summation x equal to 1 to n. Function over x, where function over x is x only, x plus x n times. Okay, we know it results in n into n plus 1 by 2. Okay, anyway, do we have another thing? Okay, what you have 1 plus 2 plus 3 plus 4 plus 5, this is what we want. Let's divide it into n different parts. First part is 1, 2, 3, 4, 5, 6. Can I make every part exactly same? Yeah, we can take. Consider first part is 2x minus 1, second part is 2x minus 1, third part is 2x. Are you joking? How it's possible? Okay, take x as variable. Yeah, I have taken x as variable. First part is 1. You are saying 2x minus 1. Then x equal to 1. 2, 1, 1. Yeah, nice. Next is 2. But again you are saying 2x minus 1. Yeah, x equal to 3 by 2. Oh, 3 by 2. Okay. Then 3 minus 2. Correct. Then third one is 3. Then 2x minus 1. Then what is x? X is 2. 2 into 2, 4. Yeah, correct. Next one is 4. Then 2x minus 1. What is x? 2 and half. 5 by 2. 5 by 2. 5 minus, yeah, correct. Means I have another formula 2x minus 1. Now all the part we have taken 1, 2, 3, 4, 5, 6. This is make things more robust that how to use successive integration, successive approximation. Now we have 1, 2, 3, 4, 5, 6. Rather than I am writing 2x minus 1, 2x minus 1, 2x minus 1, 2x minus 1. Minus 1. How many times? Okay, that we will see. 2x minus 1. Now where x is 1, 1 and a half, 2, 2 and a half, 3, 3 and a half, 4. Means what I am trying to say, I have another function. When x equal to 1, then I have a height of 1. When x equal to 1 and a half, then I have height of 2. When x equal to 2, then I have height of 3. X equal to 2, height is 3. X equal to 2 and a half, then height is 4. X equal to 3, then height is 5. I have taken deliberately this kind of equation, 2x minus 1. So this line, if I touch all the top point and if I connect through a line, then this line equation is 2x minus 1. Okay, y equal to 2x minus 1 dy by dx equal to 2. Means the slope will be more than 45 degree. Anyway, now this is 2x minus 1 is also a discrete function. Means it is not a continuous line. It is sampled at half, 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 not 1, 1, 1. Half, half, half it is sampled. At x equal to 1, x equal to 3 by 2, x equal to 2, 5 by 2, up, 3, 3, 3 and a half, 4 like so. Half, half, half it is sampled. The question is arising that can we add all the verticals? All the vertical. Vertical starts from x equal to 1, 1 and a half, 2, 2 and a half, 3, 3 and a half like so. And this is the x value. Actual vertical is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can we compute like so? Can we think about another function called gx, and gx is a continuous function. This is not a discrete function. Gx is a completely continuous function, completely. Okay, fx is 2x minus 1, it is a broken function, point mass function. Continuous function is also called density function. Gx is a density function, fx is a point mass function, which is sampled at x equal to 1, 1 and a half, 2, 2 and a half, 3 like so. Can we consider one area between two sampling? What do you mean by two sampling? Sampling between 1 and 1.5, can I consider one area strip? I can consider this is 1, this is 1.5, one area strip that will go and hit Gx. Then this area strip area is from 1 to 1.5 Gx dx. Can this area, can this area be same as left hand side fx, that is at x equal to 1? At x equal to 1, fx means 2x minus 1 at x equal to 1 should be same as limit 1 to 1.5 gx dx. Or if I take, this is called area, I have taken right hand side. If I have a vertical, if I have a vertical at x equal to 1, then I have taken area strip between 1 and 1.5 that hits gx. I can take left side also, area on left hand side. Then fx 2x minus 1 at x equal to 1 is same as 1 by 2 to 1. 1 by 2 to 1. Area I have taken left hand side, gx dx. Now gx will be different. Gx will be different. If this gx, it talks about the right hand side area, then another gx1 or g2x will be different. Okay, can I take third one? That is what we will talk now. What do you mean by third one? Third one means if I have 1, if I have x equal to 1, I have fx 2x minus 1. I'll take both side of it as area. Means if area is sampled, if I am sampling this area at half, 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 then I take quarter before and quarter after. Then it will form area strip, because area strip width must be half, because sampling we have done half, half, half. So this x equal to 1, then I'll take gx limit from 1 minus quarter to 1 plus quarter, and then I'll do gx dx. This third gx will be different than what 2 gx we have talked. I mean fx at x equal to 1 will be same as integration 1 minus 1 by 4 to 1 plus 1 by 4 gx dx. Okay, you have to find gx. What I'm trying to say, then how you will calculate the complete summation. Complete summation. If I talk about complete summation, okay, this is complete summation from x equal to 1 to x equal to 1, 1.5, 2, 2.5, 3, like so. Then x will go up to n, but there are 2n minus 1 verticals. Okay, if I say x will go up to n, then there are 2n minus 1 verticals. Makes sense? Because equation is 2x minus 1. 2n minus 1 vertical will be there if x starts from 1, 1.5, 2, 2.5, 3, 4.5, 5, 4, I'm sorry, whatever, 4, 4.5, 5, like so, and then at the end I have n. The number of vertical will be 2n minus 1. Okay, in that, if I add all the number of vertical, then it is same as I'm adding, I'm adding for each vertical, I have a sub area around the vertical for each vertical. Okay, that sub area goes 1 by 4 left side to 1 by 4 right hand side. So there are 2n minus 1. There are 2n minus 1 sub areas are there, where x will go from 1 to n. Next, where x will go from 1 to n, which correspond to 2n minus 1 vertical, but x will go from 1 to n only. Okay, if I talk about the complete area of gx, then it will go x. It will go, the first area section will be 1 minus 1 by 4 to 1 plus 1 by 4. Like the last one, that is x equal to n, the last sub area will be n minus 1 by 4 to n plus 1 by 4. Net will go as 1 minus 1 by 4 to n plus 1 by 4. Means integration 1 minus 1 by 4 to n plus 1 by 4 gx dx will give the net summation, where one sub area corresponds to the middle vertical in fx. Means if I have any x equal to x, then fx is 2x minus 1, and this vertical, the height of this vertical will be exactly same as the area strip from x minus 1 by 4 to x plus 1 by 4 gx. This is gx dx. Means fx equal to 1, fx equal to x minus 1 by 4 to x plus 1 by 4 gx dx. I have to find gx. Now, if I find gx through this fundamental, then net calculation I can do to compute the net net summation. Thank you very much. Can you try now? Yeah, we'll try. Fx equal to limit gx dx. Fx is 2x minus 1. Then dx will be dfxy by dx. That will be 2. We'll start with 2. Dx is 2. 2 dx, that will come at 2x. X minus 1 by 4 to x plus 1 by 4. 1 by 4, 1 by 4, net gap is 1 by 2 because it is sampled at 1 by 2. If it was sampled at 4, consider it was sampled at between 4, 4, 4, then I would have taken x minus 2 to x plus 2. That is the thing. If it is sampled at 1, 1, 1, then I would have taken x minus half to x plus half. We will patent it. I mean, no one has invented this procedure to find some series. Anyway, now we will take x minus 1 by 2 to x plus 1 by, x minus 1 by 4 to x plus 1 by 4. Integration of 2, that is 2x. 2 I can keep outside. X plus 1 by 2, x plus 1 by 4, x plus 1 by 4 minus x minus 1 by 4. 1 by 4 plus 1 by 4, 1 by 2 into 2. It comes as 1. It comes as 1. Expectation is 2x minus 1, but result is coming as just 1. Means I have to multiply by 2x to get 2x. Minus 1 we can leave right now. Okay, in that manner, we started with 2. I have to multiply with 2x again. So it will become 4x. So this is called successive approximation. Step by step, we are doing the approximation. Now we'll start with the 4x. 4x integration will be 2x square. 2 I can keep outside x square. X square means x plus 1 by 4 whole square minus x minus 1 by 4 whole square. If I set the limit, then x square and minus x square, they will go. Now this side we have 2 into x into 1 by 4. That side I have minus 2 into x into 1 by 4. 2 into x into 1 by 4 will be x by 2. X by 2, x by 2. It will become x. Okay, outside 2 is waiting. And now we have 1 by 4 whole square. 1 by 4, x plus 1 by 4, 1 by 16. That side again 1 by 16 minus. Both, they cut each other. And finally it will come at x into 2. 2x. Wanted it 2x minus 1. Here we are getting 2x. Alright. Now I have to settle down the order of 0. Order x to the power 1 order, we have settled it. Order of 0, that is 1. We'll try for the 1. So we started with 4x as gx. So we will do minus 1 is required. So we will do minus 1. 4x minus 1 we will try again. 4x integration will be x square 2x square minus x. 2x square will finally, it will become as 2x only. 2 4x integration is 2x square. Limit x minus 1 by 4 to x plus 1 by 4. We already saw that at the end it will become 2x. So we can just write 2x minus x, just x. X will become x plus 1 by 4 minus x minus 1 by 4. It will become 1 by 2 minus 1 by 2. But wanted is 1. We are seeing 1 by 2. We will double it now. So we will take as 4x minus 2. We had taken 4x minus 1. We'll take 4x minus 2 and we'll try again. Okay, 4x will become 2x minus 2. 2 integration is 2x. 2 will keep outside. X will become x plus 1 by 4 minus x minus 1 by 4. 1 by 2 into 2, 1. Perfect. It becomes 2x minus 1. Means gx safely I can take as 4x minus 2. And this is the result. 4x minus 2. Okay. Now to compute the final summation, then we will do the integration from 1 minus 1 by 4. That will come as 3 by 4, I believe. 1 minus 1 by 4 will come as 3 by 4 to n plus 1 by 4. Dx is 4x minus 2. X 2x square minus 2x. 2x square minus 2x. Limit is 3 by 4. 1 minus 1 by 4, 3 by 4. 2n plus 1 by 4, we will settle it down. 2x square, 2 I can keep outside, n plus 1 by 4 whole square. N square plus n by 2, n square plus n by 2 plus 1 by 16. Okay, minus it is n square, x square, minus 3 by 4 whole square. That will come as how much? 9 by 16. 1 by 16 minus 9 by 16. It will come as minus 8 by 16 minus 1 by 2. Okay, so net it came as, I believe, outside 2 is waiting. So we came as n square plus n by 2 minus 1 by 2. Up, we'll try again. N square, oh sorry, n square plus n by 2 minus 1 by 2. Minus 1 by 2. That is the result. Okay, outside 2 is waiting. So it becomes 2n square plus n minus 1. 1 by 2 by into 2 is minus 1. So we got the result 2n square plus n minus 1. Now we have now minus 2. Minus 2. So minus 2 integration will be minus 2. X minus 2 I can keep outside. X is n plus 1 by 4 minus my x is 1 plus 1 by 4. N plus 1 by 4 minus 3 by 4. That will become n minus 1 by 4 minus 3 by 4. 2 by 4. N minus 1 by 2. N minus 1 by 2. Minus 2 is waiting outside. 2n plus 1 plus 1. 2n plus 1. Hop. Okay, I'm sorry, minus 2n plus 1. If I settle down, 2n square plus n minus 1 to minus 2n plus 1. 1 gone. N minus 2 and minus 1. It came at 2n square minus 1. If people are watching our previous video, then it is previous session, then it is exactly same. If I had taken right hand side area, left hand side area, it came at 2n square minus n only. Again it is coming at 2n square minus 1. So 2n square minus 1 is the solution. Anyway, actual question in the examination is 1 plus 2 plus 3 plus 4 plus 5 plus 105. 105 equal to 2n minus 1 means n equal to 106 by 2. N equal to 106 by 2. That will come as 53. So n equal to 53. That I have to put here 2n square. Or if I take n as outside common factor, then n into 2n minus 1 is the result. 53 into 2, that is 106 minus 1. 53 into 105, that is the solution. 53 into 105. Someone will say, I know actual solution is n into n plus 1 by 2, where n is 105. 105 into 106 by 2, it will come as 105 into 53 only. Same. Okay, but I took this path so that this procedure, what we are talking about, successive approximation, will be more clear, because it is an art only to place the limit. If limit is perfect, then solution is okay, but it is not a different approach. Approach is same only. Through generic approach. Anyway, I thought of starting another one, that is x to the power 3, and that is mind blowing. X to the power 3 means I have x axis, x equal to 1, 2, 3, 4. At x equal to 1, fx is 1 to the power 3, 2 to the power 3, 3 to the power 3, 4 to the power 3. Can someone compute it? Let's divide into n different parts. One part is 1 to the power 3, 2 to the power 2 to the power 3. Someone can say, go with the x to the power 3. X to the power 3 means x to the power 3 x time. X to the power 3 dx, x to the power 3 dx. This is repeated addition. There is another way called repeated addition. X to the power 3 dx. That will be x to the power 4 by 4, 0 to n. Means it will be, in a way, the solution will be n to the power 4 by 4. It will be relative to that, but actual will come through successive approximation only. Fx equal to x to x plus 1 gx dx. X to x plus 1. Previously we did x to x plus 1 by 2. or x minus 1 by 2 to x, or x minus 1 by 4 to x plus 1 by 4. Here it will go x to x plus 1, or x minus 1 to x, or x minus 1 by 2 to x plus 1 by 2. We will do only one way, x to x. In that only I'll start sweating, that is I'm sure about it. So x to x plus 1 gx dx equal to fx, and fx is x to the power 3. Someone can take as an assignment what is repeated, what is the sum series for the x to the power 3, or n to the power 3, or 1 cube plus 2 cube plus 3 cube up to the n to the power 3. Someone can start and try to find. I believe the solution, the actual result will be little surprising. This is what I think. So anyway, this procedure is absolutely new. Anyone can see in the notebook or whatsoever. Just go through any high profile differential equation book, multivariable differential equation, multivariate differential equation, or partial differential equation. So many research papers are done. But if someone understands these intricacies of calculus, all are like reading novel only. That's it. It is that straightforward. These small intricacies are missing in anyone's knowledge, and they jump here and there. That's it. Anyway, is calculus is that simple? Certainly, calculus is that simple, but it is very complex if someone does not follow it procedure by procedure. Anyway, we do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.